Hi, so let's continue with the second part of our snake game implementation. So, generally, when with test driven development, what you want to do is leave with a failing test, right? So, we left uh, with the first meaningful test, which was failing at the time, and we'll resume from there. So, just to recap, what we have till now is a snake interface which has an orientation uh, class and a move method. It has get head orientation, which is basically fetching the position of the head at any given time. This will probably change, having thought more about the implementation um, was last few hours or so, last hour or so. Let's say, let's see. Okay, let's resume. This was our test, right? Head position should change as per orientation. Now, uh, for the snake game, one thing I was thinking about was when we view the snake game. Uh, so there were two kinds of actions. One is it changes direction, and then second is its movement. The user action is nothing but the change in direction, and the movement is sort of automatic. Like it's not something that we control or accelerate in any way. Movement is just automatic. So the user input only changes the direction of the snake, which means we need to have the snake in its behavior needs to have a method which changes only its direction. And since we have this orientation which encapsulates both the position and direction, this is not gonna work for it. So basically, what we need is a method which says change direction and it takes as input a direction enum, right? So this is probably what we need, this behavior. Um, Again, not gonna put it directly in the interface. First, we need to like model this behavior, then we'll come back uh, to make a test pass. Okay. Anyways, let's resume where we were. And we'll come to this change direction method after we have done implemented the move method. So move method essentially is whatever snake's current orientation is, it will move in that direction. That's all it does. So the head, its head will move in the direction of its current orientation, right? Uh, okay. So the test that I had written was when when a snake gets created, its head is at origin, so 0 comma 0, and its direction is up, and then we make the snake move, which means it should go up, which means its x coordinate should stay the same. X coordinate should remain 0 and the y coordinate should become 1, and that's what we want this move method to do. Now as you can see, I don't have any like okay, yeah, so a bunch of things are going to need to change to make this particular test pass. So first of them was be the head orientation, right? It needs to update. So I'm implementing the move method. So head orientation is the field that it was going to manipulate. This incidentally was not being set originally. We'll set it now. And in the constructor for snake, we will basically initialize the orientation to its original value and set that. Now again, orientation class, this implementation is based only on like the minimal details needed to make the UT pass. This itself will again change just for this single unit test. So as you can see, in test driven development, When you're writing a unit test, you're not testing behavior of a single method or a single class. You are testing the behavior of the whole system as a whole. And just to make this test, single test pass, I'll have to make changes in like multiple classes, and that's how it should be. Okay, so let's go with that. So my test first is this is if I run this test, uh, the session failing is the y coordinate should be 1 after moving. So get y coordinate orientation. This always returns 0, right? So if it always returns 0, this cannot reach 1, which means and there is an earlier test, an earlier session where it can return 0 as well, which means this can't be a static value. I need a, a private variable which lets me change this value, and I will return y. Okay. Uh, Second is obviously how do I set it? Right. It's a private variable, so we'll come to that how we'll set that. And same thing can be done for the x coordinate. So actually, let me not touch the x coordinate. Let me just do it for y first. Then I'll write a test for when we change the direction x coordinate will come into play. Okay, so y coordinate returns y, and this needs to get set, right? So when do we get set it? Firstly, when we create the orientation class, so this needs to have a constructor which takes as input y, this dot y plus y, okay, and when we are, so y is 0, actually just this video doesn't become excruciatingly long, I'm gonna add x now. Okay, x, this dot x equals x, right, and this will return x, and here I'm initializing it to 0 comma 0. Actually, let me take a quick pause here. I'll Okay. So where was I? Yep, head orientation. It. I'm also adding direction for good measure. Okay. Up and all my tests should still pass. Let me see. Yep, all tests are all passing. Even though I have changed the implementation details, instead of like hard coded values, I'm returning proper instance variable values, and and my tests are still passing. So this is the kind of freedom you get with TDD. Yeah, find the behavior in the in I defined the behavior. Implementation was incorrect, and when I change the implementation to correct uh, in the correct way, just by running tests, I know that I haven't missed anything. So I might still have, but yeah, for the most part, basics are there. So where was I? I was on the move step. So I have asserted that this is the initial orientation that gets set. Now when move is called, uh, the y coordinate needs to be increased by one. This dot head orientation dot y. So I need to set, and this is something that I don't want anyone to be able to modify, right? And if I add a setter in orientation, and that looks like that's what I'll have to do. Mm, I'll be breaking encapsulation. There'll be a leaky abstraction, something like that, right? But we'll fix it. So again, my focus is just to make my current test pass, which is void set y int int y test y equals, and what I'm doing when I'm moving is this dot head orientation dot set y to 1. I'm hard coding again, and my test is passing now. So again, my implementation is incomplete. This is clearly wrong, but it's good enough to make my test pass. Okay, next I need another. I need a better test. So if I call move twice, then y should become 2, right? Uh, and move twice after creation, y should become 2. So I have snake, and I have added snake, added snake dot move, and added snake dot move twice, and this should become 2. I'll remove this. Uh, Not really relevant for this one. When I run this, will fail. I need to make this pass. Let's go fix the move implementation. Now what I should do is set y is equal to this dot head orientation dot get y coordinate plus one. So I'm just incrementing this plus one. There's no logic related to direction yet. It's a single directional snake as of now because we have not implemented change in direction, and that's why it's not captured in any of the tests. And yeah, so so okay, so this test again is passing. What now? I think we're set with moving with the single direction UT tests. Now we need to have implement a change, direction change, right? So public void change direction. Change direction. Yeah. So direction should change entered entered value. Okay. So what we're doing is we have a snake factory dot create snake. Uh, what we need to do is so first I will get the orientation head orientation equals snake dot get head orientation. I will assert that the direction of head is up. Next, I will do snake dot change direction to direction dot left. Okay. So two things are missing here. Uh, let's add them. We need a direction called left, and we need behavior in snake to change its direction. Okay. So after I do this, it still wouldn't compile, I think. Let me just add the method. Okay. Now I need to add an assertion dot assert equals. Now what should be the direction? Direction should be left, right? Not right, left. Okay. Uh, head orientation dot get direction. Yeah, I'm not thrilled about exposing this orientation like that, considering it has a setter for y and will soon have a setter for x. So the design will definitely change, but for now we'll work with this. Uh, so I should have a failing UT. At least my UT is done by now, and I will move next to make this UT pass. So again, pretty straightforward. Head orientation dot set direction. Direction is not there. Set direction. 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 Uh, direction. Okay, makes sense. Should pass, right? No? My, okay, this is hard coded, right? And as you can see, my unit test is catching it. Okay. Uh, so I didn't write a unit test that was specific to the implementation of this getter, right? And this was incorrectly implemented earlier from before. I forgot to update it, but then somewhere in the development cycle, I will put in add a UT, hopefully that does make that code run, and as a result makes it tested. So yeah, that's what happened again. Moving on. So I have change direction method created. Now there are certain restrictions uh, in terms of what direction we can take and not. So let's go over those. So what happens if direction is opposite of current direction? So in Snake, I think if it's going up and you press down, doesn't do anything, right? It can't do a U-turn, but it doesn't error out either. So it doesn't like break your game. It just doesn't do anything. Set change is not change. Does direction stays same? Okay, so now I will assert equals dot up snake dot next set change direction dot. Now opposite of up is down. I don't have down. I'll add down. Assertion dot assert equals the direction should stay as up. Now let me run all my tests. Okay, so it's expected to stay up, but it has changed to down. That is because we have not put in any validations here. So, so and this rule, by the way, is applicable to snake. It's not a rule for an orientation class. So this check needs to be in the snake's implementation. Uh, just a little nuance there. I would not add the condition here. I would have it here because it's the snake's behavior. So if direction dot, so as long as it's not the opposite, uh, I will allow to set. Otherwise, I will ignore. That's the way. So head direction dot get opposite. There is no get opposite. That's fine. Is not equal to direction. I will set the direction. I need dot, sorry, get direction dot get opposite. Right. So direction needs to have a field called opposite. So direction private direction opposite and private direction opposite. Oh, default boundary. Sorry. Uh, what's illegal forward reference? Illegal forward reference. So in this case, I guess I would have a private method that sets. Hmm, right. Okay. That's fine. This is where you use a static block, right? Up dot opposite equals down, down, up, left, dot. Mhm. Okay, so I think this should pass now. See, it's passing. So what I've done is in the direction enum, I've defined opposites. Up's opposite is down, down opposite is up, and uh, return. So I have still not added right, and again because I didn't need to make this test pass, and that's why I did not add the right direction. Okay, so if the change direction is opposite of current direction, the direction stays the same. What happens if the direction is same as the current direction? It doesn't really do anything, right? You'll just set it to the same value. I don't think we need to implement any behavior there. Uh, okay, what should we do for what test can we think of that would require us to add a right direction? Okay. Uh, public void change direction. Mm, mm, Let it. I'll just add. Let's hard code this. I mean, change direction. Yeah. If I guess this should really realistically have create two unit tests. One is instead of doing this opposite of correction down. Uh, okay, in direction. I think so. It will come up eventually. I'll just duplicate this test. Direction underscore left to right, and this one will be up, up to down. So not equal snake matching direction left, right, and there I'll add it now. Failing test. What I need to do is define the opposite relationship between left and right. Okay, this should make my test pass. Okay. How many tests do I have? Okay, okay. Now I think we need to add more tests for move method because our move implementation was not complete either, and it was only moving in one direction, which is y coordinate, because we didn't have chain direction first. So chain direction should come before the move method, frankly. Uh, let's do that. Let's order our methods that way. I will move. Okay, so I am in the process of writing unit tests for move method. So if you move twice after creation, y should become 2. This is not a great test. Can break in all sorts of scenarios. The way we initialize the snake changes, this Qt will start breaking rate. So it did serve its purpose when I was implementing, but now I think might make sense to remove the CUT. Anyways, we'll keep it for now. Uh, what is the next behavior for move? Yeah, so all kinds of moves. Uh, when you are moving right, when you are moving right, the x coordinate increments. Now how do we capture move right? Okay, yeah, current direction is up, right? Current direction is right. When current direction is right, uh, on move, it's like this. X coordinate will increment. It makes sense. So snake equals snake factory dot create snake dot set change direction to right. Okay. So first I need to assert the direction before the move, and then orientation, head orientation, before move equals snake dot get head orientation assertions dot assert equals 0 head orientation dot get x coordinate. Then I do snake dot move and my assertion should say assert equals 1 head orientation. Okay, current direction is right. Influence on move. So this did not happen. So let's find out why. Because it didn't happen because we are not changing. So let's say we just increment the x every time we move. This is not there. Now this will make the current UT pass, but I would expect other UTs should fail. See, as per orientation test. But because we had asserted all three values here, and so good thing is we cannot just game the system on this time in this way. So let me pause it for a while. Okay. Yeah, where were we? Yeah. Give me a sec. Okay. Uh, yeah. So we were going to implement the move. So we can't just blindly increment the x and y coordinates. We have to consider the direction. So right now, this is the what we need to do is first we are writing the UT for moving right. So if head orientation dot equals right, then we need to increment this. So all UTs are now passing. So next, I need to write a unit test. Similarly for all four directions. Current direction is left, x coordinate decrements on move. Snake dot snake snake dot snake dot. One thing we could do is have a snake in the setup method because we are kind of repeating this. But anyways, so how will refactor our tests, right? Red green refactor. You don't just refactor your code. You also refactor tests in test driven development. Mind blowing, right? So much work to do so little. It's like you're catching your ears like this. Feels like that. Snake dot change direction dot left. Offset y0 dot x coordinate -1. So what we'll do is head orientation dot get direction dot first direction dot left head orientation dot. Okay, feel like it's down to refactor a bit. Let's run all the other tests as well once everything's passing. Um, I'll hold off on the refactoring for a while. We'll just do this. Add two more tests. Current direction is down. Y Z decrements on move. Now this is going to have a funny, something funny is going to happen. I have a feeling in this one. So uh, to make the direction down, I cannot just do change direction to down here, right? Because it will not change the direction. So to make the direction down, I need to first do change direction to left, then change direction to down. So the snake has turned. Uh, Head orientation, yeah. And we are interested in y coordinate. Before the move it is 0, and after the move it should become -1, which is not the case. So when I go here, I need to put head orientation direction, uh, direction down, head orientation dot set y orientation dot get y equal +1. Okay, so if I do this, so it failed, and I know why it failed. This is because I have a set y here, which will first increment, and then also this is wrong, right? So it will still fail. Right. Now I need to comment this out, but as soon as I comment this out, This test will pass, but there are two other tests that start failing, and that is obviously because of this. So, final nail in the coffin goes up. Dot apply. Plus one. Okay. Okay. All the tests are passed, and my snake can move in all four directions, and it doesn't move in. Yeah. So now let me refactor this a bit. Firstly, what I want to do is use switch instead of if. Let me see if IntelliJ can. Okay, no mind. Switch get direction case up. Okay, okay, that's one part of the refactoring. Everything is still seems to be working. Next is I don't want to use setter for this because in this game we are only changing one. We are only moving it one at a time. I'm gonna replace this with increment y. Uh, increment x. This should be decrement x, increment x. Wait. Okay. This is much more readable, I think. Now, based on direction. Y. If it's down, you're saying decrement y. Similarly, if it's left, you're saying decrement x. And if it's right, increment x. So I think readability is better. So change direction only. Okay, I think this is a good place to stop. Stop here.